Good afternoon.
Good afternoon.
Good afternoon.
So how's everyone today?
Doing pretty good.
Oh, great.
So did anybody do anything amazing over the weekend?
We had a robotics competition in Gilbert, and we took first.
What? That's awesome. So how many teams were there?
23.
23.
Wow. So why do you think you took first?
Because we have the world's best driver,
Who's that?
Rachel.
Oh, wow. That's awesome. That is super cool. All right. Anybody else? All right. Looks like everybody's here. Okay. Well, let's see. What did I do that was amazing? I blew out an engine in my car. I don't know how amazing that is. But fortunately, it's still under warranty, so that's okay. I did see Ford versus Ferrari. If you are into cars or you like car movies, it's a really good one. Anyway, it was a lot of fun. Okay, so let's go through the week. So today we are going to finish 4.5 and maybe finish 4.6 as well. All right, and then what I'm hoping to do is actually have finish 4.7 tomorrow, because I'm not quite sure what's going to happen later this week. I might have mentioned that I knew that that this Wednesday and Thursday, I might just be days where you take quizzes and the chapter 4 test. And so I'll kind of figure it out. I thought maybe I would do a video or something, and I might still do that for Wednesday. But I'm pretty sure Thursday in class, well, I'll just say right now, Thursday I'm not planning on doing a broadcast, but instead we will do a Moodle day, okay? And so we'll just kind of see how it all shakes out, all right? So Thursday, we won't have a class broadcast, but you will have some Moodle quizzes or the chapter 4 test if we're able to finish it. Okay. Let's see. Any other questions or concerns about this week? Let's see. Oh, Jorn was asking and emailed me about putting the curve in for the midterm, so I did that. Thank you for the reminder, Joran. So hopefully your grades will be updated on that. Let's see. Okay. So we'll all communicate with the talent aides as well, and once I kind of figure out exactly how Thursday is going to go, and then kind of go from there. But like I said, there will not be a broadcast on Thursday, but we might just have it be a Moodle day. Okay, to get kind of caught up. Okay. All right. Well, let's kind of pick up where we were on 4.5. We were on practice 5, and I had asked you to kind of see if you could finish this one up. Let's change the. There we go. Okay. So we were talking about about maximizing and minimizing things, and this one is to maximize profit. And so when we're looking at how to maximize profit, what we want to do is figure out. I think I want to do this problem a little different than. Or did anyone actually work through this? Anyone have the answer for us yet? Okay. Well, what we're going to do is to where the notes that I'd given right before this said, if you want to maximize profit, you set the marginal revenue and the marginal cost equal to each other. Okay. So I'm going to do that. So the marginal revenue is the derivative of the revenue. So R prime is just 9. The marginal cost is the derivative of the cost function. So that's 3x squared minus 12x plus 15. All right. So then if we set those equal to each other, we get 9 equals 3x squared minus 12x plus 15. Okay, so if we want to, I don't like that 15. So if we want to solve that, that's a quadratic. So we want to have it set equal to 0. So let's subtract 9 from each side. Here, let's get rid of that. Okay. So to set it equal to 0, we're going to get 3x squared minus 12x, and then 15 minus 9 is going to be plus 6. And so then to solve that, before I worry about factoring or anything, what could I do to make my life a little easier here?
Take the 3 out.
Take the 3 out. So if I divide everything by 3, okay. Then I'm just putting the 0 to the other side. So I get x squared minus 4x plus 2 equals 0. Okay. Now, if that doesn't factor, then probably what's the best way to solve it?
Quadratic formula.
Quadratic formula or the graphing calculator. Either way, I would say let's do that. So here, I just use the quadratic formula here. So A is 1, B is negative 4, C is 2. Okay. And so then, actually, I've set this equal to 0. So this is the, let's get rid of that. Okay, so I get the opposite of B, 4 plus or minus negative 4 squared minus 4 times 1 times 2 all over 2 times 1. So that's 16 minus 8 is 8. So 4 plus or minus radical 8 over 2. The square root of 8 simplifies to 2 radical 2. And so now you can actually factor out a 2 and cancel. And so you get 2 plus or minus radical 2. So, but you know, if somebody says, well, how many? What is this? units. How many units should I make? And you say 2 plus or minus radical 2. See, that's no good. That doesn't help anybody. So then you want to write this as a decimal. So 2 plus or minus 1.414. So 3.414 and 0.586. Okay. So how do you make 0.586 units?
It's thousands of units, so you have to
Thousands of units. Very good. See, that's a kind of mistake that's easy to make on a test or a quiz. So it's in thousands of units. So you need to multiply these answers by 1,000. So how many units do you make? You make 3,414 units or 586 units. So what happened to the 586? Why did I not include that? How do you know which one of them? Here, let's go ahead and put that up there. So 586 units. See, where the derivative is 0, that's the max or the min. So how will I know? How do I know which answer's the max, which answer's the min? All right. Nathan, do you have an idea for me?
I have a question. Can the minimum be higher than the maximum?
No, because higher is the y value. The highest y value is the maximum.
So then wouldn't it be 3,400, 400?
I'm sorry, your rude classmate was coughing over your answer.
Yeah, that was Joey. He's a bit of a snob. Would it be 3,414 then?
And how do you know that?
Because the minimum can't be higher. What? Confused.
Well, but
I know it's...
remember, these are x values.
Yeah.
So how can you know which one is going to produce a bigger y value?
Wait, I have an idea. So
Okay.
this is like the most you're getting per unit. Like these two are optimal, but you want to have the biggest number because that's going to produce the biggest profit with the best profit per unit.
Not necessarily.
Is it because
More isn't always better.
is it because the original function was a cubic and you know that that goes up the higher the next?
So as a matter of fact, you know it's a cubic because and so by the function dance, you know it goes like this. And so so the first x value is going to be the max. The second one is going to be the min. See, now if it was a negative x value, if the original function is negative, let's see. Let's go. If the x cubed was negative, actually, it is going to be negative because the profit function, see, the profit function is the revenue minus the cost. So if we set it up that way and just look at the profit function, it's going to be 9x minus x cubed. And so it is going to be the opposite direction. So it's odd negative. So instead of going like this, it's going to go like this. Would you stop it? It is actually going to go like this. Or here, let's exaggerate it a little bit more. So it will, as a cubic that's negative, it will go like this. So the first function is, the first critical point is going to be the minimum. And the second critical point is the maximum. So that means it's the 3,414 is going to be the maximum. But that might be confusing how I just explained it. Okay. Is there a way that we could know for sure without being confused by Mr. Strong's crazy explanation there with the graph?
Would
plug
you
it in.
Plug into the function. Okay? And so you plug into the function, whichever y value is bigger, that's going to be the max. Whichever y value is smaller, that's going to be the min. So you could just plug in, and that would do it without fooling with the graph or knowing the function dance or any of that. You just plug it in and see which one gives you the bigger value. Now, with the function though, you would plug in the 3.414 and the 0.586, and then that would give you the profit. Okay? All right? So the revenue minus the cost would give you the profit. Okay? All right. Any questions on that? All right. So how would you figure out the average? Let's see, what's the next one? To compute average daily cost, divide the cost per cycle by, what do you divide by to figure out average?
365.
So if you know the annual and you want the daily, then you would divide by 365, or the number of days in the cycle. Okay? So if you want the average cost in a week, you would divide by 7. In a month, you divide by however many days are in the month, or you divide by 365. Okay? So just for notation's sake, and really this is the only reason why I put this one on here, is the notes here, is for average, the average of a variable, we use a line over it, and that means average. So for average cost, you take the cost divided by X number of days or whatever. Okay? All right. Okay, so we're going to skip practice 6, and I want to go to the notes for part 7. Marginal change. How would we determine the rate of change of the marginal cost? Any ideas there? The rate of change of the marginal cost.
Would you take the derivative?
Of?
The derivative.
The derivative of the derivative. That's it. The second derivative. So rate of change, when you see that, take the derivative. Marginal, when you see that, take the derivative. So both of those things mean take the derivative. So it would be C double prime of X. Okay? So take the second derivative. Okay, so that's it for 4.5. Any questions before we move on? Okay, well, let's go on to 4.6. Okay, now, something else I was going to tell you, not fell over. So next week, do any of you guys have school on Wednesday? Any of you have regular school? I mean, I know NPC has classes on Wednesday. But what I'm going to try to do is figure out a way so that maybe you don't have to come to school on Wednesday. So maybe we'll do I'll have quizzes where you can take them from home or something like that. Okay. So just to let you know that I'm trying to work it out so that you don't come to school on Wednesday. So is that okay with everybody?
Yes.
Okay. All right. So more details to follow on that. I just kind of got to get through this crazy week before I start working on next crazy week. But I'm just wanting you to know that, I mean, we won't have class obviously on Thanksgiving Day, but MPC normally has classes the day before. But since none of you have school, I kind of am thinking, we'll figure something out. Maybe you can take a quiz or two at home or something, but not have to come to school. So anyway, well, I'll figure it out. I'll let you know. Okay, so 4.6, Newton's method. All right. This, if you'll notice on your sheet, this is just one side of notes, just 2 practice problems. It's a really short lesson. Okay. And so, so we'll be able to finish this, and hopefully these problems will be super easy for you. This is all like number crunching in the calculator. Okay, so let me explain what Newton's method is all about. So first of all, finding square roots. Newton's method is a technique to approximate the solutions of f of x equals 0. So and this is actually what your calculator uses to find zeros or roots or x-intercepts or anything. So like if you have that and you put it in your calculator and you do second calc 0, your calculator is actually using this method. Okay? It's using Newton's method. Okay, so let me explain what it is. All right, so here's the idea. So let's say the blue curve is a function, and you want to find the root, or 0, where it crosses the x-axis, okay? So the idea is that you start off with a guess. So like, let's say x of 0. Usually your calculator will, it'll come up with its own guess. Usually I'll tell you where to start, just so we have the same numbers, okay? But you start with a guess, and we're going to call that x of 0. All right, now, if you follow x of 0 and you go up to the graph, the curve, and you take the derivative at that point, so f prime at x of 0, then you'll get the slope of this tangent line right here. And so where that tangent line crosses the x-axis, that's a better guess. See, x of 1 is closer to the real answer than what we started with. So then we do the same thing. We go and we plug x of 1 into the function and then take the derivative at that point. And so the slope of the tangent is going to lead us to x of 2, which is better still. All right, then we come up and we do it a third time, and x of 3, we're pretty dang close. And sometimes we can be, after x of 3, we can be within 100,000th. Okay? Now, what your calculator does is it goes through like 100 iterations of this formula. We're only going to do 3. Okay? All right? So, all right, so the procedure for Newton's method. Okay, number 1, guess a first approximation to the solution. A graph may help. Okay, usually I will provide this first approximation. Usually provided. And so that first guess, we're going to call that x of 0. So I'll tell you, start at 1, start at 0, or whatever. Okay, now this is the key thing right here that's highlighted. Use the first approximation to get a second, the second to get a third, and so on, using the formula. So this is saying the next guess is the previous guess minus that function value divided by the derivative value at that point. So because the next guess involves the previous guess, this is what's called a recursive formula, where you keep using the last result to get the next result. Now, a couple of comments here. The most common mistake that people make is with the formula. They'll put a plus here, or they'll put the derivative on top and the function on the bottom. But it's the function over the derivative. Okay? So that was exactly, well, and then I guess the next common mistake is plugging it in wrong in the calculator. So let's kind of see how that goes. All right? Okay, so.
Could you go back for 1 second, please?
Yeah, sure.
Sorry.
No, you're
Thank
good.
you.
Just let me know when you're done.
Okay, thank you so much.
You bet. Okay. So let's just watch this one, okay? It's going to be very similar to your practice problem, so you don't need to write this one down. Just kind of watch it. So if I'm going to approximate the square root of 2, that's the same thing as using this function, f of x equals x squared minus 2 equals 0. So x squared equals 2 is the same thing as x squared minus 2 equals 0. Okay? You want to rewrite your function, set it equal to 0. All right, then you want to take the derivative. So f prime of x is equal to 2x. All right, now you have to have a starting point. So let's say I tell you I want x of 0 to be 1. Okay, so that's where we're going to start. Then what we do is we say, okay, now x of 1 is that answer, 1, our starting point, minus the f of 1, so 1 squared minus 1, over f prime of 1, 2 times 1. So we work that out and we get 1.5. Okay, so now that's going to be my next guess. So for x of 2, it's going to be 1.5 minus, okay, now I plug in 1.5 into the function, over 1.5 into the derivative. So 2 times 1.5. So then I put that in the calculator and crank it out. Now, usually on these, you want to carry it out to 5 decimal places because you want to see how it's getting closer and closer to the answer. Okay, and now one more time to get the x of 3. That's all we're going to do. So x of 3, so you take the last answer minus, then you plug that into the original function, over plugging it into the derivative, and now you get it. Now, I took it out a lot more because what I was trying to show here is that we're actually accurate here to the 5, to the exact value for the square root of 2. And so that's the millionths place. So we're accurate, and really the computation isn't all that hard. But this is how they used to compute square roots, okay, before the days of calculators. They'd work them out like that. Okay, so I'm going to leave this up on the board, and I want you to do practice 1, and I want your x sub 0 to also be 1. So start with 1 for this one. All right, so Aiden, what did you get for x sub 1?
Is it 1.732143?
Nope, it's just 2. Okay, so the derivative of x squared minus 3 is just 2x. Okay, you're going to start with x sub 0 equals 1. So then your next guess is going to be 1 minus, so you plug that into the function and you get 1 squared minus 3 is negative 2. And then you plug 1 into the derivative and get 2. So 1 minus negative 1 is positive 2.
I'm sorry, I thought you said the second one.
Oh, okay. So what did you get for x sub 2 then? So what did you say again? I forgot what you said a minute ago.
75.
All I heard was 5. Say it one more time, please.
1.75.
Okay, there you go. 1.75. All right. And any questions on that? All right. And then, so the x of 3 All right, Denon, what'd you get for x sub 3?
Um, 1.73214.
Excellent. Okay. And so just so you know, we're accurate to, let's see, 10, 100,000. So the 10,000s place. We're accurate here after only 3 iterations of the formula. So that's what I'm saying. Your calculator actually does it like 100 times, to get it more accurate. Okay. And that's how it's doing it. Okay. So any questions on that? Okay. So now, we can also, Newton's method is the method used by most calculators to find zeros and intersection points. All right, so let me demonstrate the intersection idea. So so let's say we want to find out where, let's just go to says find the x coordinate where y equals x cubed crosses the horizontal line y equals 5. Okay. All right. Now, so this is, if we're trying to find the intersection, then see what your calculator, what you do actually is set those two equal to each other. So you get x cubed equals 5, because they're both equal to y, then set it equal to 0, and think of this as your original function. And so now go ahead and see if you can do Newton's method on this. And again, start with x sub 0 equals 1. And so go through the same process again and see if you can get it. All right, so Denon, when you've got x sub 1.
2 1/3.
2 1/3. Okay. So 2 1/3 or 7/3. Okay. Any questions on that? All right, David, when you've got x of 2. All right, you stuck?
I believe it's negative 0.01 or negative 0.1005.
Okay, I got 1.86168. So it's going to be 7/3 minus the f of 7/3 over f prime of 7/3. Okay, so you've got to put that 7/3 into the function and work that out, and 7/3 plug that into the derivative and work that out. Okay, so somehow, and so you might want to even, do that to the side if you're having trouble doing it all in one step. Just work it through. All right, and then the last one, the x of 3. Aiden, what do you get for that?
Is it 18385?
No, it's 1.72200. Anybody get 1.722?
Yeah.
Okay. So let me show you a couple of calculator tricks. Let's, in case it's the calculator. Now, this is not in the book or anything. This is just some tricks that I've developed in doing these. Okay. So the first thing that I want you to do is put in the original function. Well, when you solve it, set it equal to 0. Put that into your calculator for y1. Okay? So just type in y1 equals x cubed minus 5. And then put in your function, the derivative for the y2. So y2 equals 3x squared. All right? Then the next thing, whatever your x of 0 is, you store that in for x. So it should look like this on your screen. 1, and then the store key is right above the on button. So if you do 1, store, and then there's the variable key x, and press enter. And so you'll see a 1 over here on the screen. Okay? Any questions to this point? Okay, so now what you do is you're going to kind of use the formula, and you're going to plug it in like this. You're going to have x, so that last guess, minus y1, so that's the function at that point, divided by y2, which is the derivative at that point. You're going to store that in for your new x. Now, if you don't remember how to get the y1 and the y2 up there, so you do x minus, okay, to get the y1 and the y2, you go to variables, y variables, function, and then it has the list. So that would be y1, you just press enter, divided by, and then to do y2, you go through it again. Variables, y variables, function, and this time you go down to y2. And then you're going to store that value. So store again for the new x. And then you press enter, and when you press enter, then it works through and it gets you your x of 1. Now the beautiful thing about putting it in as a recursive formula, now to get the other x values, just press enter and enter and enter, and it just gives you the next iteration of the formula. So you press enter and enter and enter, and then it just updates the x each time. So you only have to type in the formula once. It might pop up on the screen each time, but you're only having to type it in one time. And so if you kind of practice with it, man, it can make these easy.
That's all.
Could you show us how to get x as a value again, real quick?
How to get what?
How to make like x is equal to 1.
Oh, okay, so you just use the store key. So here, let's clear this out. So you do 1, store, x, and then enter.
How do you delete it off of it if you want to?
It will stay in there until the next problem when you pick a different value for x.
Okay, and then if you're wanting to put an x like as just an x value, how do you?
Well, then, it won't affect the graph. It's just
okay.
what's stored in there. So it'll just stay until you change it to something else. Okay? All right, well, we're about to drop off. So that's it for 4.6. So we'll start 4.7 tomorrow, and then we'll talk. You guys have a great day.